It will depend upon the number of observations you have. Then it will also depend upon what is the regression that you are doing. For example, if your regression is alpha plus 5 IT minus 1, right? But in your simulation, you have assumed alpha to be 0. But in the real world, there is an alpha. Then obviously your t-statistic will be wrong because you are testing a wrong null hypothesis, right? So therefore, it's important that, or suppose, so this is called a random walk with a drift. This is called a random walk with a drift, right? This is called a random walk with a drift. Or your actual process could be alpha plus 5 yt minus 1 plus delta et plus del t plus et, where t is a time trend. So a process which has a time trend as well as a random walk. In which case again, if you neglect any of these variables in the simulation that you are doing, you have to tell your computer what is the functional form that you use to do a simulation. So you have to be very clear about getting this right. This is called the data generating process. Okay, it's called the data generating process. And it's important that you specify the correct data generating process for the computer to generate, to simulate the distribution of P gamma hat. Right? Simulate the distribution of P gamma hat. Right? We did some work in class, but we did a very preliminary thing. Okay, the book by a man called Walter Enders, Applied Econometric Time Series. Okay, in Applied Econometric Time Series, there is a flow chart about how you would actually do this. How you would actually find out from your data whether there is a drift, whether there is a time trend, whether your data are non-stationary, given the right combination, right alpha, and whether alpha actually exists or P actually the trend actually exists. Right? Okay. So please look up Walter Enders, Applied Econometric Time Series, to be able to understand the actual mechanics of this procedure. But the idea is clear, how everybody does, how to do a decay-Fuller test. Sure? Right? It's a simulation based test. There is no underlying distribution. Okay, there is no standard because when the data random walks, there is the test and the statistics like T, F, chi-square don't follow any standard distributions. Right? You don't have a standard formula that it's a standard normal upon the square root of a chi-square divided by its own degrees of freedom. Those formulae don't apply. Right? Okay. And if you take a course in time series 1, when you are in the 3rd semester or the 4th semester, you learn the maths of why that really happens like that. Sure? Okay. So this is, we are done with the decay. Now friends, suppose we have rejected the null. Suppose we subjected the data to the decay-Fuller test and rejected them. We have a time series process. Yt is equal to alpha plus 5 yt minus 1 plus e. And suppose you have rejected the null that phi is equal to 1, which means that phi is stationary. Okay? Right. So let's characterize the mean variance and the covariances of this process. This is then called a stationary AR1 process. You write this as an AR1 process, autoregressive of order 1. You call this process autoregressive of order 1, AR1. Right? Why do you call it autoregressive? Because you are regressing yt on yt minus 1. Okay? You are regressing yt on yt minus 1. So it's an AR1 process. The stationary AR1 process, the absolute value of phi is less than 1. First, let's find out what is expectation yt. What do you think will expectation yt be? There are two ways of finding out expectation yt, right? One is to realize, I can write this out here, okay? And then realize that this can be written really as alpha plus phi Do you agree with this? Right? Instead of yt minus 1, I have written yt minus 1 alpha plus phi yt minus 1 plus et minus 1. Because yt is alpha plus phi yt minus 1 plus et. Yt minus 1 will be the whole thing pushed back by 1t. Okay? So what does this become? This becomes, so I have yt is equal to alpha plus alpha phi plus phi square yt minus 2, right? Sure? This I can write as alpha plus alpha phi yeah? Sure? And I can keep on doing this till it becomes 1 o'clock. Right? But obviously I'm not be doing it. So this is equal to alpha plus alpha phi plus alpha phi square should be phi et. If I kept on doing this many times, say some j times, then I can write this as j plus 1 times, say alpha plus alpha phi plus alpha phi square plus alpha phi cube up to alpha phi raised to j plus something plus et plus phi et minus 1 phi square et minus 2 plus. Sure? Now, as j tends to infinity, we have agreed that, you see, this part can be written as, so this whole thing can be written as alpha into 1 plus phi square plus phi cube plus to phi raised to j. Sure? Plus, of course, et and so on. Right? Now what is this? This is 1 plus phi square plus phi cube plus phi raised to 4, where the value of absolute value of phi is less than 1, so it's a geometric series. Right? And what does that converge to? 1 plus phi square plus phi cube, etc. What does that become? 1 upon 1 minus phi. So as j tends to infinity, this will be written as alpha upon 1 minus phi plus, then, so essential point is yt is alpha upon minus phi plus et plus phi et minus 1 plus phi square et minus 2, so on, right? So what is yt really? Yt is alpha upon 1 minus phi, some constant, plus the current period shock, plus phi into the previous period shock, plus phi square into the shock 2 periods back, plus phi cube into the shock 3 periods back, plus phi raised to 4 into the shock 4 periods back, and like that into the indefinite future, right till the time Lucy came out of Africa and went to the rest of the world, right? Okay, sure. So you have this, sure. Okay. Now the point is, what is the expected value of yt then? So what I am interested in is first, remember it's a very important equation, so I will not rub it out. Make sure everybody understands this very well, right? No doubts? Pakka? So what do you think will be the expected value of y? Alpha upon 1 minus phi. Yes, correct. Why would that be? Because this is a constant and the expected value of a constant is a constant. So this becomes alpha upon 1 minus phi plus expectation Et plus phi expectation Et minus 1 plus phi square expectation Et minus 2 and so on. And what is expectation Et? 0. Expectation Et minus 1 is 0. Expectation Et minus 2, they are all 0. So this becomes alpha upon 1 minus phi. So the long-term mean of this process, the unconditional mean of Yt is alpha upon 1 minus phi. So if Yt were 2 plus 0.5 Yt minus 1 plus Et, what will be expectation Yt? 2 upon 1 minus half, 0.5, which is 2 upon 0.5, which is 4. So expectation Yt would be 4 in that case. What would that be? That would be the long-term mean of Yt. That would be the average value of Yt. Right? So what you would expect Yt to be, if you do the graph of Yt, you would expect Yt to have a mean of 4 and Yt to be, values of Yt to be fluctuating around that mean. So if you drew a graph of this process, that graph would look like, it would be a straight line at 4 and values of Yt would be fluctuating around that 4. Yeah. And those fluctuations will be the ETs. Right? And the fluctuations will be uncorrelated because ETs are uncorrelated. Everybody gets this? Yes. Now, what do you think will be the variance of Y? Now you see the key point here is, if phi is equal to 1, then what happens? What if phi is equal to 1, what happens? What is expectation Yt? Undefined. Because what will you then get? You will get Yt is equal to, alpha plus alpha plus alpha plus alpha. All the phi's will be 1, no? You get alpha plus alpha phi plus alpha phi square, etc. So you get alpha plus, right? So you'll be counting, adding many constants infinitely many times. If you add a constant infinitely many times, you don't get a finite quantity. So you will not get a finite representation for Yt at all in the first place. Right? So you can't really, you cannot definitely, there is no meaningful quantity called Yt, which is a finite sum of some past values. And therefore, you really can't have this. Because that geometric progression doesn't happen. Right? If you say phi is equal to, that is what is meant by saying expectation Yt is undefined. It's not, don't think of it mechanically as alpha upon 1 minus phi, so phi is equal to 1, so that quantity is undefined. It's not that. Because if phi is equal to 1, you don't get alpha upon 1 minus phi. You get alpha plus alpha plus alpha plus alpha plus alpha plus alpha plus alpha ad infinitum, which doesn't mean anything. Right? Which really doesn't mean anything. Right? If I kept on adding 1 plus 1 plus 1 plus 1 plus 1, does it mean any quantity? No, it just keeps on becoming an infinitely large sum, that's all. Right? Okay, so it's right. And therefore, the key idea is if only phi is equal to 1, is the long-term mean defined. You must have now begun to see the statistical problems of having phi is equal to 1. So the mean of a process is not really defined. If the mean of a process is not defined, you can't take, say, some sample mean and subtract from it the population mean, expected value, and divide by the standard deviation and get a standard norm. Because that long-term mean is not defined. You can't square it and say it's a chi-square. Right? So those things don't exist. That's the problem. Right? That's the problem with non-stationary data. Is everybody getting it statistically? Yeah. So, now tell me, what would be the variance of Y?